what exactly is a document? When we want to collect all the initial data into a set of files that we are going to then process in the tokenization and linguistic preprocessing phase, we are making, it's not a trivial task. That's what we saw last time. Because in order to work with documents, we need to be able to extract the character sequence in the documents. Because ultimately, a document is a sequence of bytes in a file, right? That's how it's stored on a machine. And we need to take the sequence of bytes in the file, in the document file, and convert it or extract from it a character sequence, a sequence of characters. This sequence of characters is what we will then tokenize. So we were assuming in this diagram of a pipeline that we have the character sequence already extracted, but there will be an initial step where we need to take documents in various formats, languages, and encodings and extract this character sequence out of each of those kinds of documents, and that may not be a totally trivial task. So documents can come in different formats: PDF documents, Word documents, Excel, HTML, and so on. And to extract character sequences out of each of these kinds of documents is going to require us to to use different techniques. And mostly information retrieval people don't do this. They basically use licensed libraries to convert PDF into a text file and so on. So ultimately, we have to assume that all these documents have already been decoded, and we have obtained the character sequence out of them. Of course, if you're looking at HTML document, even after converting it into a text file, you may still need to process that text file and remove all the markup that's in the HTML document, because markup is not something you want to index. Markup is basically meta information, and that kind of information can be discarded. So we actually want the body of the text when we parse the HTML file. Also, we want to figure out what language the text is in, because we've seen in the first chapter that the tokenization and linguistic pre-processing steps depend on the language. The kind of tokenization you'll do and the kind of linguistic pre-processing you'll do depends on the language, and so we need to know the language of the documents in advance so that we can use the appropriate schemes for tokenization and other kinds of normalization. We also need to know what character set is in use. Uh, there are different kinds of character sets: ASCII, Unicode, UTF-8, and so on. And in order to convert bytes into characters, we also have to know what character set we are using, or what character set the document is using. Now, each of these tasks, figuring out the format, the language, the character set, is a classification problem. Recall from chapter 1 that a classification problem is one where you have a predefined set of classes, and you also have a set of examples of typical documents in each class. And then you train the machine to recognize documents in each of those classes, so that when you get a new document, the machine will be able to classify it in one of those existing classes. So there is something called supervised learning, which is a particular subfield of machine learning. And classification is an example of supervised learning, where a machine learns to recognize the different classes by you having to provide it examples of typical documents that lie in each class. So it's supervised because you are like the supervisor who is providing a standardized list of examples for each of the classes to the machine. So the machine will look at each of those examples, try to figure out patterns from those examples, patterns that are unique to each of the classes, so that when you, after this training phase. So there will be a training phase where you show the computer these different examples of documents belonging to all the classes. And the computer will learn how to recognize each of the classes because it will extract patterns characterizing each class in the training phase. And then in the test phase, you have a new document that's coming in, which is not classified, which is not labeled. So the machine doesn't know which class it belongs to. And you feed it to the machine, and the machine will use the knowledge that it has accumulated in the training phase to classify the document in the test phase. So whether the classes correspond to different formats of documents or different languages or different character sets, it's the same classification problem. And we're going to study classification in more detail later in the course when we look at the machine learning section. But very often, these classification tasks are often done heuristically. For example, we saw last time that if you can just figure out what the file extension is, that can often give you the file format. If you look at the document metadata, that can often tell you what the character set is. And similarly, if you look at um, some of the words in the document, assuming that you know what the character set is, if you're able to extract some of the words, you can probably figure out what language the document is in just by looking at a few words. So um, using a combination of machine learning and heuristic techniques, we can extract the character sequence out of the sequence of bytes. And we're going to assume now that we have that character sequence extracted. Some complications in this are, for example, when documents that you are trying to index are heterogeneous. In other words, there's no single language that is found in the documents. What if some of your documents are in German, some of them are in French, some of them are in English? In that case, your single index is going to contain terms belonging to several languages. And you'll need to do tokenization and linguistic pre-processing separately for documents belonging to different languages. Now, that's something you ideally would want to avoid because if you are the person building the search engine, you clearly have some language in mind, and it's impossible for one single person to think about um, doing tokenization and linguistic pre-processing for multiple languages. In some cases, a single document itself could contain multiple languages or multiple formats. For example, an email in English could quote, say, a speech in French, in which case a section of your email would be in French and the rest of it would be in English. Sometimes the attachments that you send with your emails could be from other languages. You can have a French email with a German PDF attachment. So these are some complications that you need to deal with if you plan to build an IR system for the web. The other thing that you need to decide, so this is about extracting the character sequence. So this slide up to here is about the task of extracting the character sequence from the sequence of bytes making up the documents. The other issue you have to worry about before you actually start this pipeline, before you can consider this initial step to have been done, is to decide how you're going to define a document. One simple way to define it is every file that I'm having is going to is going to be a separate document. So if there are 37 plays of Shakespeare, I'll have 37 documents. because the number of documents you define is going to determine the IDs that you'll be assigning to each of those documents. Now, in some cases, you may not want to define a document as a single file. For example, the Unix mbox stores all your mails in a single file called the mbox file. If you want to index this kind of a file, then you probably want to split the file into its individual emails, and you want to make each email within the mbox file into a separate document. So this is an example where you may want to split a single file into multiple documents. What if you have an email that has 5 attachments? In that case, you may want to convert the body of the email into a separate document and each of the attachments into a separate document. So you will have 6 documents being created out of this email. What if one of the attachments is a zip file? In that case, you may want to unzip that file and then look at all the files that were zipped and convert each of them or define each of them as a separate document. In some cases, people often convert PowerPoint presentations or LaTeX presentations into a sequence of HTML pages so that they can be viewed easily on the web in a browser. In that case, a single file, a single original file, say a PowerPoint file, would be split into a sequence of HTML pages. If there were 30 slides in the PPT file, this process would generate 30 HTML pages. So you don't want to treat each HTML page as a separate document here. You may want to combine those 30 pages into a single document, which is sort of the converse of what you're doing here, where here you are splitting a single file into multiple documents. Here you are trying to merge multiple files into a single document. Now suppose you have let's say you have a book, right? Let's say you take a single play of Shakespeare. Even there, you may want to think about whether you want to define a single document as the entire play, or do you want to consider certain, if you want to break the play into a sequence of sections and say that each section is going to be a separate document. Let's say you have a huge book in PDF format. You may want to split that book into individual chapters and define each chapter as a separate document. Now, why would you want to do such a thing? Why would it make sense sometimes to split an entire book into a number of documents instead of treating it as a single document? What are the advantages and disadvantages of doing that? Is there a use case you can think of where this may make sense? Let me actually give you an example so that maybe you can think about why you may want to do this. So let's say there is a book from the Middle Ages. Okay, let's say there's some historian writes a book on the Middle Ages in Europe. Now in that book, you're probably going to find the word Christ appearing. Because naturally when you study the history of Europe in the Middle Ages, you'll be studying pretty much the history of Christianity, because that would have been the dominant religion in Europe at that time. So you'll find the word Christ appearing at many places. Moreover, the university system that we have today was initially started in the Middle Ages in Europe. So you would probably see the word university also appearing in some of those chapters. Now suppose your query was Christ University. would this document be relevant to you? Would this book be relevant to you? This book on the Middle Ages in Europe? Probably not. But, because Christ appears in the book and university appears in the book, maybe in entirely different chapters, or even if they appear in the same chapter, on different pages of the same chapter. Certainly they won't appear side by side like this. In that case, if you define the entire book as a single document, this query, Christ University, if treated as an AND query, okay, if treated as an AND query, would return this book and many other such documents. Now suppose we were to split the entire document into a sequence of paragraphs. Right? If you were to take the whole PDF file, extract the character sequence from it, and convert each paragraph into a separate document. In that case, you will probably have very few, in fact, it's very unlikely that you're going to find Christ and university appearing in the same paragraph. Because when the university system is being discussed, probably religion is not going to be discussed, or even if it's discussed, it'll be discussed in a generic sense, not, you know. Uh, so I hope you're getting what I'm saying. By refining your definition of a document, you will be increasing the chance that if if the search engine is returning you a list of documents for this query, it's very likely that those documents are talking about Christ University, because if Christ and University are appearing very far from one another, as they will in many of the online books, then you don't want that to be returned in the result. So my question to you is, recall these terms, precision and recall, that we discussed last time. Is it possible to say what would be, consider a scenario where you treat every book, no matter how large it is, as a single document? What would what would the search engine that you would get as a result of that be called as? What would its performance be? Would you say it's high precision? Would you say it's high recall? Would you say it's low precision, low recall? Think of a query like this, and think of a document like this, and think of a scheme where every document, every file is turned into an individual document, including huge books. So would the precision be high? Do you remember what precision is? We discussed this last time.
Precision is a fraction of reduced of the calculus, and recall is fraction of relevance of the calculus.
Can you speak into the microphone? For some reason I couldn't hear. The voice is very faint.
Precision is a fraction of reduced dots that are relevant, and recall is fraction of relevant dots that are retrieved.
Yeah. So if in your sequence of results, you're getting a lot of irrelevant documents, as you will in this case, because you'll get many of these, books which mention Christ and university, but, not appearing next to each other, but appearing in totally unrelated ways somewhere in the book, inside the book. You're going to get all those books in your uh, result. So that would be low precision, right? The precision would be low because many of the documents that were retrieved were not relevant to your information need. Your information need was you're interested in finding out information about this entity called Christ University, which is in Bangalore. But what you're getting in your results is a number of documents which mention Christ and university, but not referring to Christ University, but referring to, university and Christ, two different and separate entities. So as your document size grows, it is more and more likely that you're going to get examples like this, where the words in your query are all appearing in that document, but they are appearing so far from one another that the document is really not relevant. When if you entered 2 or 3 words in your query, you expected those 2 or 3 words to be basically found next to one another, or at least in the same sentence or same paragraph maybe. But because they are being found in, at a great distance from one another inside the book, all those would be returned as well. So the precision would be low, but the recall would be high, because if a document is relevant to you, if there is a document referring to Christ University, it's definitely going to be in the result. The problem is that it's not just these kinds of these documents that will be in the result. You're also going to get other kinds of documents. That's the problem. So you're going to get low precision and high recall. So if document size is too large, then the precision will be low and the recall would be high. What if the document size is too small? Let's say you change every sentence um, into a separate document. Well, maybe you would still do well, because Christ University, strictly speaking, is a phrase query. So if you expect a reference to it, you probably expect it to be found in the same sentence, right next to one another. But let's consider another example. Say Chinese toys. Now this is not necessarily a phrase query, because you can think of Chinese toys as toys made in China, and it's possible for uh, Chinese and toys to appear not together, but not too far from one another, so that that paragraph itself is talking about toys, and it's referring to the fact that there are Chinese manufacturers for it. So that kind of a paragraph would also be relevant to you. But what if you make the document size too small? Maybe there are some relevant documents where the word Chinese appears and the word toys appears in the same paragraph, but not in the same sentence. So if you were to make every sentence into a separate document, then you would lose these associations, right? You would lose these documents. Do you see that? If the document size is too small, that is, for example, if every sentence is converted into a separate document. Then when you search for Chinese toys, when you search for a query like Chinese toys, you're going to get a list of documents in the result, which will be such that the word Chinese and toys appear in the same sentence, right? By definition, because every sentence is being treated as a separate document. So all the doc IDs here correspond to sentences where the word Chinese and the word toys both appear. But my point is that in the corpus as a whole, there could be many other, uh, or if you look at the original corpus, if you look at the original corpus from where you changed every sentence into a separate document, in that original corpus consisting of large PDF books, it's possible that there was there were many references to Chinese toys, but they were references where the word Chinese and the word toys did not appear in the same sentence but appeared in adjacent sentences. But by converting every sentence into a separate document, those references would not be returned in the result, because one sentence would just have the word Chinese, so that document wouldn't be returned. Another sentence would just have the word toys, that document wouldn't be returned. So in this case, the recall would be low and the precision would be high. Why would the precision be high? Because you're assured at least that whatever results you're getting are probably relevant, because these are all results where Chinese and toys appear in the same sentence. But why is the recall low? Because in the corpus, there were many references to Chinese toys where Chinese and toys did not occur in the same sentence. And you basically don't get those references in this result list. So I hope you see this trade-off here between what happens if you make the document size too large and what happens if you make the document size too small. On one hand, you'll get low precision and high recall, and on the other hand, you'll get high precision and low recall. Any questions about this? So you need to avoid either extreme. And of course, there are no set rules to avoid either extreme. You basically have to think carefully about the kinds of documents that you're dealing with, the kinds of users that will be using your system, and you need to think about the kinds of queries that they will be submitting. Hello?
Yeah, yeah. Excuse me, sir.
Yeah.
Yeah, I have a question. When you're saying the dock size is too big or small, can you give any specification, like how big it is in whether is it in MBs or GBs?
So the question is not whether it's too big in terms of MBs or GBs. The question is more about the kind of language, the kind of queries, and the kind of users that will be using your system. So, I mean, think about just an entire novel like, um, think of any your favorite novel, right? You pick a random word from the first chapter of a novel, a random word, but a word that is relatively rare. Okay, not articles or anything like that. and you pick a random word from the last chapter. And suppose somebody were to give a query with two words, one of them being that word from the first chapter, the other being the word from the last chapter. Would that book be relevant to that query? It won't be, because there's no reason why that document would be expected to be relevant to that user, because the idea of entering, when we think of the kinds of queries you yourself enter on Google, right? You would mostly be entering phrase queries or queries where you expect the words to be found close to one another in the document. But if the document size is too large, you increase the likelihood that you will find all those words in the document, but they will not be close together. The larger the document you choose, the larger the likelihood that those words will be present, and they'll be present in unrelated places. That's all I mean by saying the document size is too large. It's not a question of how many MBs or GBs. Of course, think of a typical PDF book, that would be MBs, right? It won't be, I don't think, a typical novel would be more than 1 or 2 MB in PDF form at least. So even that could be pretty large. That could be too large. Maybe you want to index each page separately, something like that, or each paragraph, or each section. I mean, it depends on what documents you're looking at, really. So as I said, there is no set rule here. Like there's no universal rule saying this document size is too large, or this one is too small. It depends, and these are things that you learn more by actually doing it, evaluating the performance of your system, then changing things and seeing if the performance goes up or goes down. I mean, there's no mathematical definition of being too large or too small. You have to see what maximizes your performance.